Hi dear students, let's see this question that was asked in KVPY 2019 essay part 1 physics paper. The question is from the topic of vernier calipers. The question is simple, but because of one particular thing, most of the students got this question, or most of them got confused. Eventually, they got this right, but they got confused. So let's see what's happening over here. This is a vernier caliper which has a main scale least count of 1 mm. That means distance between two consecutive markings on the main scale is 1 mm. This is 1 mm. So 1 MSD is 1 mm. 10 vernier scale divisions coincide with 11 main scale divisions. So we can say that 10 VSD equals to 11 MSD. So from here 1 VSD is equals to 1.1 mm. Okay. Now this is interesting. In most of the cases that you have seen in vernier calipers, the main scale division is more than vernier scale division, but over here it's opposite. Now this is what got confused, like this is what made students confused, right? So we have to find the least count. So in the usual vernier caliper you write least count as main scale division minus vernier scale division. Over here we are going to write opposite. I'm also going to explain how will this vernier caliper work, or how will we take the reading on this vernier caliper. That will be interesting thing to understand actually, right? So first let's find the least count. Least count will be one vernier scale division minus one main scale division. So which is equals to 1.1 mm minus 1 mm. So which gives us the answer 0.1 mm. Hence the option A is the correct answer. Now many students, they wrote 1 MSD minus 1 VSD and got negative 0.1 mm, and they got confused why are they getting negative sign. But actually since here vernier scale division is more, so we are going to take vernier scale division minus main scale division. Now it will be an interesting thing to see how will this vernier scale work. Okay, now I'm going to draw two vernier calipers, one usual one and the second one, which is this. Okay, so suppose this is the vernier scale of a regular vernier caliper. This is a regular vernier caliper and this is the main scale. So this is the zero of the main scale. This is the first division on the main scale. The second division. This is the third division. Okay. Now note now remember that here the vernier scale division will be less than main scale division. Okay, and vernier scale will be sliding on this. So suppose second reading of the vernier scale coincides with main scale. So this sort of scenario is happening. This is the zero of the vernier scale. This is the one of the vernier scale. Okay, and this is the two of the vernier scale. Okay, so basically this length we have to measure. This length we have to measure, right? This is the length we have to measure, and this is the regular vernier caliper. Okay, this is the regular vernier caliper. This length we have to measure, right? Now, basically, what will happen in this case? Basically, see what we will do. We will say that reading on the main scale is 1. Okay, 0 of the vernier scale is right of the 1. So reading on the main scale is 1. So we are going to say 1 plus, okay, 1 main scale division. Hold on. Yeah, 1 main scale division plus 2 into least counts. So actually this distance is 2 into least count. Okay, which is easy to see. This is 1 MSD and this is 2 MSD. So total of this is 2 MSD. This is 2 MSD, right? And this is 2 VSD. You can see this is 2 VSD. So this distance you can see is 2 into this distance, a small distance is 2 into uh, least count, right? So 2 LC. So that's why this total length will become 1 MSD plus 2 into least count, right? Now, suppose we have a different vernier, we have this type of vernier caliper in which main scale division is less than vernier scale division, right? And suppose we have a different length now. So basic such that we are measuring this length such that the again the second reading on the vernier scale coincides with the main scale. So we will have this sort of scenario. You can see the second reading on the vernier scale is coinciding with the main scale. So now in this case again the main scale reading will be 1 and we will subtract the least count, because see we have to measure this length. So this is what we have to subtract. Okay, this is what we have to subtract. Okay, so you can see again, this is 2 VSD, this is 2 VSD, and this is 2 MSD. So this length will be 2 VSD minus 2 MSD, right? And this much we will have to subtract. ये लेंथ हमें subtract करनी पड़ेगी मेन स्केल रीडिंग में से. So we will write 1 MSD minus 2 into least count. So the idea is that if Vernier scale division is more than more than main scale division, तो कुछ नहीं, रीडिंग वैसे ही लो एंड लीस्ट काउंट को एंड जो भी रीडिंग कोइंसाइड कर रही है वर्नियर स्केल की, दैट रीडिंग मल्टीप्लाइड बाय लीस्ट काउंट, उतने वैल्यू को मेन स्केल रीडिंग में से सब्ट्रैक्ट कर देंगे. रेगुलर वर्नियर कैलिपर में अपन ऐड करते हैं एंड हियर वी आर गोइंग टू सब्ट्रैक्ट. दैट इज द ओनली डिफरेंस दैट वी आर गोइंग टू डू इन टेकिंग द रीडिंग. So I hope you were able to understand how this type of vernier caliper is going to work. That's it. Thank you.